Good morning everyone. Let us see about the UJT relaxation oscillator. UJT is a three-terminal semiconductor switching device and it has only one PN junction and three terminals. It is commonly called as uni-junction transistor. So this is the basic structure of UJT. So here it has the term emitter, base 1 and base 2. And you have only one PN junction, and this is a symbol of UJT, and this is the equivalent circuit of UJT. Considering the characteristics of UJT, you have two resistance between base 1 and base 2. So the total resistance you have RB1 and RB2. So if voltage is applied between the two bases, so when the emitter is open, okay, a voltage gradient is established along the N-type bar. Okay, then you have the intrinsic standoff ratio eta. The voltage drop across the resistance across the base 1 terminal is given by V1, that is the intrinsic standoff ratio into the voltage, the base voltage. So the intrinsic standoff ratio is given by the resistance across the base 1 resistance divided by total resistance across the base 1 and base 2. Generally, the typical value of efficiency ranges from 0.56 to 0.75. This voltage V1 reverse biases the PN junction and the emitter current is cut off. But there is a small leakage current which is flowing between the base 2 terminal to the emitter due to the minority carriers. So if the positive voltage is applied across the emitter, the PN junction will remain reverse biased as long as the value of the emitter voltage is lesser than the voltage across the base 1. If the emitter voltage exceeds the base 1 voltage by the cut-in voltage 0.7, if the value exceeds, the diode becomes forward biased. So under this condition, the holes are injected into the N-type. These holes are repelled by the terminal B2 and are attracted by the terminal B1. So the accumulation of holes in the emitter junction to the base 1 region reduces the resistance, and hence the emitter current is increased, thereby limiting the value of the voltage. So now the device is now in the on state. The UJT is fired or it is in on state. If a negative voltage is applied to the emitter, PN junction will remain reverse biased and the emitter current will be cut off. So now the device is now in off state. So here the peak point is being considered as P. So when the diode is reverse biased, so the region is called, when it is reverse bias, it does not conduct, then it is in cutoff region. So when the peak voltage Vp is greater than, it takes the value of base voltage plus the total voltage V, then the diode starts to conduct and the holes are injected into the N region or the N layer. So thereby the resistance value decreases, which decreases the voltage across the emitter, and the current value increases. So there is a negative resistance region from point P to a valley point V, capital V. Now after the valley point, the device is driven into the saturation and then it behaves like a conventional forward biased PN junction diode. So the region to the right of the valley point is called saturation region. So in the valley point, the resistance changes from negative to positive. The resistance remains positive in the saturation region for a very large value of emitter current that characteristics approaches the curve, that is the value of current in the base 2 terminal becomes 0. So now the unique characteristics of UJT is when it is triggered, the emitter current increases until it is limited by the emitter power supply. So due to this negative resistance property, UJT can be employed in a variety of applications such as sawtooth waveform, generation of a sawtooth waveform. It can be used in pulse generators, switching, timing and phase control circuits. So in coming to the working principle, so this relaxation oscillator using UJT is meant for generating the sawtooth waveforms. It consists of UJT capacitor across the emitter junction CE, which is charged to the emitter RE as the voltage VBB is turned on. The voltage across the capacitor gradually increases as the voltage increases. So when the value of the capacitor voltage, when it reaches the peak point Vp, now the UJT starts conducting and the capacitor voltage discharges rapidly through the emitter terminal across the resistance R1. Now after the peak point, when it is reached, it has reached the peak point as the voltage has been increased, it provides negative resistance to the discharge path, which is useful in the working. So as the capacitor voltage reaches 0, it discharges, and it reaches 0, the device is then cut off. Once it is reaching 0, it is cut off. The capacitor C, again it will charge again. It will charge, discharge. So this cycle is repeated continuously, generating a sawtooth waveform across the capacitor. This inclusion of the external resistance R1 and R2 in series with the base terminals B1 and B2 provides spikes like waveforms. So when the UJT fires, there is a sudden surge of current through the base terminal causing drop across the resistance R1, which provides a positive going spike. Also, at the time of firing or when it is turned on, fall of the emitter base junction voltage causes an increase in the current I2 rapidly, which generates a negative going spike across the resistance R2. So here you have resistance across each terminals, and here this is the where the capacitance is getting charged till the peak voltage. This is the valley point, peak point, valley point is charges and then discharges, and here see the voltages here, it is generated in the form of a spike. So by changing the value of the capacitance CE or by changing the value of the resistance RE, the frequency of the output waveform can be changed as desired. Since these values is controlled, the time constant RC value of the capacitor, so you can control the time constant value. So the frequency of oscillation can be calculated. Okay, now consider the time period, the frequency of the sawtooth can be calculated. Assume the capacitor is initially uncharged. Okay, so the total voltage VC across the capacitor has been given as VC is equal to the base voltage VBB into 1 minus e power minus t by the time constant RC. Now when it is discharging the capacitor, as it is discharging, so now the point Vp is given as eta into VBB. So eta is the intrinsic standoff ratio, which is given by 1 minus e power minus t by Rc. So e power minus t by Rc can be given, so move to the left hand side, you get 1 minus eta. So now my time t will be Rc into natural logarithm of 1 by 1 minus eta, and this value comes around 2.303 RECE log to the base 10 1 by 1 minus eta. If the discharge time of the capacitor is neglected, suppose if the discharge time is neglected, consider small t is equal to capital T, The time period of the wave, therefore, the frequency of oscillation. What is frequency? Is inverse of time. So frequency F is inverse of time, 1 by T. So the value 1 by 2.303 RECE log to the base 10, 1 by 1 minus eta. So the value, so by this we are able to calculate the frequency. Okay, so first, so as the value of my voltage gets increased, the capacitor gets charges and the capacitor discharges as it falls to 0. Then again it charges, discharge, the process will be continued. So thus it forms a sawtooth waveform, and this UJT can be used in many applications. Thank you.